Okay. Guess we'll start there. Oscar, you need to enable screen sharing for me. Okay. Okay, can you see my PowerPoint? Okay, so MATLAB is a software developed in the late 70s by a professor from New Mexico University in order to enable his students to use Fortran packages that he already wrote previously without having to write any code. So MATLAB stands for Matrix Laboratory, and it's basically it's been developed. They used to apply numerical methods to solve like differential equation and stuff like that. And it uses everything is done on matrices. This is like a reminder on how, for example, transposition of a matrix works, and will provide like a recap on also how matrices operation works. So since it works with matrices, it's best used for data analysis involving raster files. It's not really the best to do analysis involving polygons and vectors, although there are toolboxes that can be implemented in MATLAB to do so. But in my experience, it's not really the best tool. I had a very hard time in the past to match some shapefile maps of the US with raster files and stuff. So it's probably not the best. But if you have data in a raster format, so in like a grid format, and you need to do analysis on that, MATLAB can be a good tool for that kind of feed. So as I said, its functioning is based on matrices, and basically for MATLAB, everything is a matrix. So a matrices can have any dimensions, as many dimensions as you can imagine. Like the standard matrix has 2 dimensions, rows and columns. Vectors are basically arrays that have only 1 dimension, and then can be represented as a row or as a column. The standard way for MATLAB to represent vectors is rows, but you can, it's like the aspect is user definable, so you can decide at the beginning if you want that to be a row or a column. And Scalars are basically considered like arrays with 0 dimensions, so just 1 element. So here, this you can see like the main aspect, the main framework of the graphic user interface of MATLAB. So here in the top, there's a panel with all the options relative to the section that you're working with. And on the left side, there's like a folder look. It's like you can see all the files that are on your system at that time, and the default folder is the folder where MATLAB is installed. So for example, Math, that you have installed MATLAB on your laptop or your computer, your default folder will be the one where MATLAB is installed. In the center part of the screen, you'll have on top the editor that you can use to write programs, which basically are sequences of commands. And in the bottom part, in the middle, there's the command window where you can just input strings, and that will operate immediately. So it can be useful if you need to do like some quick calculation that will involve too much time doing by hand, but it's not the best if you want to perform like more complicated analysis. Then it's better to like write a program and then just launch it. So as you can see, for example, here, there's this section which is highlighted in yellow. And this is just like a chunk of the program, and like in R, in MATLAB, you can run like separate chunks of your programs. And in order to do that, you first have to create these separate chunks, and you do this with this, with the percentage symbol repeated twice. So the percentage symbol, when it appears only once on a row, on a line, it stands for a comment. So that marks a line that the software will ignore while running your program. When instead you use two of these percentage symbols, one next to the other, it marks the start of the chunk. There's no need to end a chunk with another symbol, but you will just use another couple of percentage symbols to start the next chunk. And that can be useful if you want to like rerun just one portion of your program, because maybe you decided to make some changes just to that. Another interesting thing is that in order to use this button here, run, that will run the entire program, you need to save your script, like here. And by default, MATLAB will save its code, its script with this .m extension. While instead, you can still write a program and run it without saving it using this button, which is the run section, which is a section of the chunks I was talking before, like this. And that's also useful if you just want to run that single portion, that single section of your program. There's run at advanced that run the section that you have highlighted, and then stops before the next one, but it's like ready to immediately run the next one. While advanced just scrolls you through sections, let's say. Running time, it's like an automation that computes the time needed to run your program, but that's something that you can also do, like insert directly in your script, putting a tick at the beginning at like here, and a talk at the end. Here you cannot see the talk because it's at the bottom of the program for the entire, but you can do that also for section. So, if you remember the matrices that I showed you earlier, like this A, which is a 5 by 5 matrix, and this W is a 5 by 1 matrix, they will appear in this like right section of the graphic interface, which is the workspace where you have all the variables that you're using, all the files that you're opening, your folders, anything that is basically brought into play in your program or in your operations is saved here, and you can access these just by double clicking. So for example, you can, sorry, this mouse is very sensitive. So you can see our previous matrices will have this, like it's like a sheet-like appearance where you can have all the elements. And so you can inspect also the results of your analysis before even, I don't know, printing them to screen or saving them. If you think that something that's not really matching, something that is not working, it's a good idea to have a look at your workspace items to see if there's something. For example, this matrix could have missed one column. And then, for example, when you need to do operation between matrices, they need to match in their dimensions. So that can cause a problem, and you can figure out pretty easily using the workspace area here on the right. Then next, okay, so matrices, matrix operation. So the operation, like the arithmetical operators are the same as your like number pad on your keyboard, on your calculator. It's a star for multiplication, a slash for division, and so forth. So if you use like arithmetical operators with matrices, MATLAB assumes that you want to perform matrices operations. So like in this case, for example, here we have these two simple matrices, matrix A and matrix B. And this is the result of a matrix multiplication, which is broken down here. So it's basically row times column. And and then the result is summed, and it goes into each cell of your matrix. Or you can also perform operation element by element between matrices, vectors, whatever you want. In order to do that, you just add a dot before your arithmetical operator, like in this case. So doing so, instead of following the rules of matrix multiplication, here you just, for example, here we are multiplying each element of each matrix for its correspondent. So 1 times 5, 2 times 6, 3 times 7, and 4 times 8. And so we have a completely different result. This is actually very useful because you can store matrices, vectors, scalars, whatever you want, just using these expressions. So a name, the name for your item, equals, and then whatever you want. So for example, here, this notation with brackets is the same as creating this matrix. So the semicolon like divides rows, while spaces divides columns. So you can insert like a matrix this way in MATLAB, but there are also other many ways. Sorry. There are some built-in function like zeros, and so in this case we're creating a 5 times 7 matrix, all filled with zeros. Another one is ones, and you just make the same, but instead of zeros it's 1. This other function is I, and it will give you the identity matrix with 1 on the diagonal and 0 anywhere else. But there are also other operations that you can perform, like a horse cat, which basically is a concatenation on the horizontal axis. So here, I concatenated the matrix A from previous examples and the matrix W, the vector W, which originally, if you remember, was a row. Okay. It was a row. So if I wanted to merge this matrix, it's a 5 by 5 matrix with this 1 by 5 row, MATLAB would have returned me an error. So what I did here, I transposed my row into a column, basically using this operator, which is kind of an apostrophe. I'm not really sure the name in English, but in this way, the new array, capital W, is a column. And in this case, this can be horizontally concatenated to the matrix A. So you can see that the vector, the column vector, capital W, is added on the right side of the matrix. And there are way more built-in functions that allow you to build your matrices. For example, even here, for example, you can see this log space. So basically, this builds an array like a vector that goes between 10 and 100, which is like the logarithmic of 10 with exponent 1 and exponent 2. So this array will have 5 elements equally spaced. So see that this is a kind of a difficult operation if you wanted to do it by hand, but it's also very easy to implement using this built-in function. Another one is link space that will basically do the same, but using a linear progression between 10 and 100. So, okay. Another important thing that I want to mention is that, for example, using common basic statistics operation on matrices, there's some awareness to be kept when working, for example, with the MATLAB version 2017A, which is the one that actually works on the Agave cluster. So there are several built-in statistical functions to perform statistical analysis on your data. One of these is the mean to calculate the average. But if you use this function with like this matrix A, 5 by 5 matrix A, it will return the mean for each column. So your result, your output will be an array, in this case, a row vector, with contain each element will be the mean of each column in the matrix. There's a way also to change the scheme for this mean and for like specifying the dimension you want to perform the mean on. And so like in this other example, a row, here, instead of just having A in the brackets before, after mean, we have 2, which indicates the second dimension, which is the columns, no, the rows, sorry. So in this case, you'll have a column vector with the mean of each row. So with newer versions of MATLAB, they implemented a function called all that allows you to directly calculate the mean value of a matrix or over all the elements of a matrix. Although that's not available on this version installed on the Agave cluster, it's kind of easy to go around it if you first calculate the mean rows by rows, specifying the dimension here, and then you can simply perform a mean of your column vector that you have obtained previously. In this way, you'll be calculating a mean of a mean, and since it's 2 dimensions, up to this version, you have to perform 2 different steps in order to get to the final result. Okay. Then another useful function, which is motivated for Fortran, which was the inspirational basis for this language for MATLAB, are for loops and if else and if then else like statements like so these 4 are called loops, and basically they are iterative iteration of the portion of scripts included between the for and the end for the number of times that is specified here at the top of this structure. So, for example, this time in this example, the variable sum1 is initialized outside of the loop as a 0, and basically it sums itself for the time of the iteration lasts, and at the end it returns the output of this like summation basically. While you can also do this, so if you don't specify a step, MATLAB will go one by one. Well, you can also decide to change the pace, and so the spacing between iteration, like is made in this example. So instead of summing every time, the summation is performed every other time, and you see that the output is smaller. So one thing I want to say is like the semicolon, as probably I mentioned before, is in arrays is used to separate rows, different rows, while here in the script is to mute the output. So basically, without putting this semicolon here, if we ran this loop, we'll see, we would have seen in the here in the command window, all the operations performed during the iteration, during the looping. While instead, like putting a semicolon, we won't have any intermediate output until we just tell MATLAB to print to screen or to save, whatever. Conditionals are used to, they can also be used with loops instead of inside loops. And they can be used to discriminate between values if you want to like stop an iteration at a certain point or until you reach a certain threshold. You can use these kind of statements. Where the MATLAB checks the value, the current value every time, and it compares with your threshold, with your criterion, and it works accordingly. So loops can be nested. It means that you can put more or less as many loop one inside the other. If you're working, for example, with a 3D matrix, you can go through each element of the matrix using three nested loops. Of course, you'll have to change index, and given that this is k, that the next one could be j, and the innermost one could be I, for example. So if we get to, well, you'll see later during the practical example how this works in practice, actually. So let's try to sorry, Matt, I didn't see your question. Can you just not do mean? No, I don't think that works, but we can try. So okay. So who needs to get access to the Agave cluster and install everything? So who's ready for that? Let's put it that way. Who's ready for that? Oscar, okay. Matt, I know you are working on your, okay, perfect. So you know the procedure, are you already logged in, or do you want me to guide you through that?
I'm good.
Okay, Oscar?
I don't think that I'm logged in or anything, but again, I'm just following along, so don't worry about me.
Okay, if you want, the first thing you have to do is to connect to ASU through Cisco VPN connection, if you did that. Otherwise, let me know. Okay, Oscar. Okay, so here we are. Okay, let's first try suggestion. So let's yes. No, as I suspected, it doesn't work. It's not a
That's
good.
interesting because it worked on my computer.
Really?
I have 2020 though.
Oh, okay. Yeah, that might be the difference then. Yeah, it's a bummer because it's, I don't know how, but on the Agave cluster there are like more updated version installed, but they don't work. If you try to load them, you get an error, and so it's like, okay. Who needs directions to get to this point, like to having MATLAB from the Agave cluster running on your screen? Anyone?
I do.
Okay. Okay. So did you connect to ASU through Cisco VPN?
I have the Cisco installed and everything, but I don't know how to connect to it. Is it not just ASU?
No, it's like. So did you download the client from the web page that I linked in the email that I sent a couple of days ago?
The Cisco or the Xming?
Both.
I did both.
Okay, so your client, your Cisco client, should already have the address. So when you run it, there's like a drop-down menu that should have the address to connect to the ASU network. It should be something like SSP. I'll tell you in a second. Anybody else at this stage?
I'm just at a kind of terminal in the Agave cluster here. Here, I'll show you what I got going on.
Okay. Okay, Mary. So I'll write in the chat. No, I don't know how to get to the chat anymore. Okay, can you see my screen, Mary?
Yeah.
Okay, so I'm writing it here. sslvpn.asu.edu. Sorry. So if you use this address, you'll be able to connect to ASU remotely. After that, you have to run the Xming software.
Okay, I think it's working.
Nice. And then open PuTTY. So first thing in the left menu, there's a SSH, like a sub menu.
For the Xming or the putty?
PuTTY. Xming, you just run it and that's it. You don't have to do anything.
Okay, cool.
So in PuTTY, in the left menu, there's a SSH submenu, and there's X11. There you have to enable X11 forwarding.
Got it.
Okay, now go back to session on the left menu, and where it says host name, there in that bar you put your ASU ID. So I write mine, for example, it's a Brandi at agave.asu.edu. So instead of a Brandi, you have to put your own ID there and connect using the button open. It will ask you your password. You use your own password, ASU password, and then it should open the terminal, which would be connected to the Agave cluster.
Okay, I think I got it.
Nice. Okay, so you should be connected now. And wait, let me do this. Are you connected to the server? Okay, you put the password in.
Yeah, I need to put in the password.
Okay.
I did it at some point. I'm not sure what it is anymore.
Oh, okay. It's your own ASU
like
password.
is it? Okay.
Yeah,
It was
yeah,
like
the one you
about a
use
year ago when I first got the cluster stuff.
No, it's the same that you use to access ASU, whatever. Your
Yeah.
email, it's the same
Okay,
password.
cool.
So once you're there, the first thing you have to do is to type this comma, interactive, which will be used to run modules or nodes of the server, of the cluster.
Okay. Super dumb question. It is not letting me type anything.
In the terminal,
Yeah.
just because it doesn't respond to the keyboard or is not connected or whatever. What's?
It's not responding to the keyboard.
Wait, are you trying to put your password in?
Yes.
Oh no, it's responding to the password. So instead of like showing you stars, it just doesn't show you anything, but
okay.
it's taking it. So if you type in your password correctly and then enter, you'll be in.
Okay.
Are you in? Mary.
Sorry, it closed on me, so I had to restart it. There was some error.
Okay. Is everybody else ready?
Aldo, I'm not either. And I apologize a lot here.
Where are you at?
I currently have this terminal over here. You look at my screen,
Mm-hmm.
but I don't know how to open a MATLAB from there. I also have X, the X launcher thing going on, but I tried connecting to the using the PuTTY and the SSH thing, and neither of them work.
Well,
I don't really know what I'm doing here.
did you connect it with Cisco?
I did, yes.
Okay, that worked.
Yeah, I'm in Agave up here, see,
Okay.
but I don't. I tried running just MATLAB, but yeah.
No, you have to do. Have you typed in interactive first?
Have I typed in interactive? No, I have
Yes.
not. Okay, I typed in interactive. Some stuff happened, and
Okay, now you're ready to start MATLAB. Mary, are you there?
Yes.
Okay, so to start MATLAB, okay, I'll type it in the chat. It's module load MATLAB /2017A. And after that, just MATLAB. It will take a while to run, to start, but this should work. So give me a sign when you're ready.
I think it's opening right now.
Okay. Yeah, it will take a while. It's totally normal.
I think I'm ready to go.
Nice. Oscar, where are you?
I've just got a MATLAB. To get started, type one of these: help win, help desk, or demo. I think I'm okay too. I'm not seeing any sort of GUI here yet, but I assume that's going to happen in a minute.
Okay, you have MATLAB on terminal?
Yes.
Okay, that's probably because Xming didn't work, because you need that to run it as with a graphic user interface.
Okay. Well, I couldn't figure out how to get Xming to work either, so don't worry about it.
Okay, let's try this then. Okay, first of all, clear all. This is like a heading that I suggest you always have in order to have like a clean running every time. So clear whole will clear everything in when run. Will clear everything in your workspace. So it will erase all the variables that have been like temporarily stored here, and so you know that the data you're working with are those that you're examining at this specific time, and you're not working with like old variables or variables that refer to old stuff. Then close all, and this will close all plot windows inadvertently left open, and it's convenient for the same reason as above. And then CLC, that will clean everything from your command window. So for example, I can write this plus 2, and we have the result and everything. So if I go, so as I said before, I'm just writing this. I didn't save anything. So now I can run this with the run section. If we do this, see the workspace is being cleaned and everything. Okay. So let's define a path for our file. So in this case, we'll use some files that I have in a folder that I created specifically for this workshop. You should be able to access these. If not, let me know. Figure out a way. Okay, no, this doesn't need to. Then we'll use this function that will analyze all the files in the path that I specified. So again, if we run just this section, we'll have here in the workspace the file path that we were looking at, file path, and there should have been info, not into, but okay. So if you open this, see here we can look at all the files that are in my folder. With its dimension and all their identification and stuff. So there's also this practice.m, which is the code that we are about to write that I already wrote before and stored in the same folder. This let's leave this open because this will affect some operation that we will do later, and I'll show you how. So let's go back to our editor. And let's start with a loop. Why do we want to use a loop? Because we want to analyze all these files in the folder. So these are meteorological model simulation output. The model is WRF as the beginning of the file name, and these are 8 different time steps spaced 3 hours each. So from 9 UTC to 6 UTC for the next day. So this is why we need a loop in order to iteratively go through all these files, which represent different time steps of the meteorological situation in the conterminous US. I will show you this later. So for F, which we'll use to identify the file, it goes from 1 to 8 because we have 8 files because they are separated by 3 hours time steps. So to make 24 hours, we need 8 files. Now we have to do this trick, which is F plus 3, because when MATLAB will start accessing the files, the elements in the folder that we specify, the first one it will find is this one, which he sees as a folder. I don't really know what this is. I think this is something that is peculiar to the cluster, to the Agave cluster, that is created. It looks like hidden files, something that is created anytime you create a new folder on the cluster. So if you try to have MATLAB read this, it will return an error, so we need to skip this. And there's also the code itself that I wrote earlier. So we're just adding like a washer, like 3 sides washer to our counts in order to have MATLAB starting from 4 and ending at 11. So instead of having F in our operations, we'll have Fn, which will be like the modified counter. So then we need to have MATLAB read the files. And we'll do that with this function, this dot name. So with dir info, MATLAB built this structure for the content of the folder, and this Fn will work as our index. So it will start reading the file name from Fn equals 4, which corresponds to our first file. Okay. Wait, someone. Okay, thank you, Matt, for the information about Unix functioning. Thank you. I didn't know that. Okay. So then we create this other variable which contains our file path, and our file name. Then we create a variable where all the content in the file is stored in this variable called data with capital D. So MATLAB is case sensitive, so data and data like this can be and will be, as you'll see, two different, no, not in this example, but this can be two different variables. So it's very important how you use lettering. Variable names have to start with a letter, but after the first digit, the first character, and the rest can be alphanumeric, but they have to start with a letter. So we use the function load to store all the content of the file in our variable. And for now, we close the loop like this. Okay. So we are not indexing data. So even though it will iterate through all 8 files, in the end, we'll just have one data variable, which has 189 rows and 309 columns. We can access it in the workspace, expand, and we can see directly all the values that are stored in this variable right now. If you want to look at want to see what this looks like, just out of curiosity, we can do this. pcolor data and rerun. Okay. Okay, so this is a sensible flux. Maybe this is not the best because it's bedtime. It's 2 a.m. in the morning, so there's not much. Okay, so let's do a modification. Let's index these, and let's say that we want to wait. Let's first see how many. Okay. No. Okay. Just a second. Yeah, I do that too. Huh. Okay. Let's do it another way. Oh, sorry guys. I don't know what's going on. Okay. So now let's do this. Doesn't change much. Okay. Okay, so for example, here, it's a usage of another function, which is pause. So if you put this into your code, it will like get idle until you press a key and you start it again. So here it's inside the loop, so it will stop at every iteration. So if I press here, it will go on, but it will stop again. So let's block it. And let's see if we get a better picture. Okay, yeah. This makes a little bit more sense. If you can see my screen, you have an idea of what data we're working with. These are sensible heat fluxes for North America with a 20-kilometer resolution as simulated by the meteorological model. Okay, so let's go back to our code. So now we want, for example, to see the diurnal variation. Okay, bye, Mary. We can have a look at the diurnal variation of sensible heat flux for the city of Atlanta, which I already retrieved the cells, the corresponding cells in our raster file already. So we can do a nested loop. So we'll nest another loop inside this one. And this time this will go from 1 to 4 because we only go through 4 columns. And we hold yes. We'll have to tell the model though that the specific number of columns that it has to go. So although there are 4, we'll do the same trick again. So the columns we want to consider are from 225 to 224 or 28. So in this way, we're adding 224 numbers to the original counter. And this will be necessary because if we did like something like this, we'll get an array or a matrix. Oh. We'll get an array or a matrix that has 224 empty elements, empty columns, rows. I'm not sure now which way that would be arranged, but it will start. It also always starts from 1. So if you tell him to go from 225 to 228, it will build like an array which will be full, so from 1 until 228, but we have the first 224 items empty. So with that trick, we go around MATLAB logic, and we create another variable that we index this time. So instead, now 69 to 72 are the rows where we want to the mean to be performed. So as maybe you remember, the standard way for MATLAB to calculate the mean is column by column. And so we are specifying which rows in those columns that we are setting the columns here, while here we're specifying the rows that it has to consider in order to calculate the mean. Matt, you could do that like simply running the mean for 69 to 72 and 225 to 228. Okay, Mary, oh no, Melissa, sorry. So you should be able to access my folder in the home folder, because I can access anybody else's folder that's contained in the home one. So if you just follow these directions, this should work. Have you tried the first attempt? So if we mute these, we run this. Okay, and so do you get the same information here about the folder? No? Okay, very good. Okay, so that's not good. We can go around this. If I share with you my data, you can download them and upload yourself in your folder. Okay. So using this link, you access a Google Drive folder where the same files are stored. If you download it to your laptop and then you upload it to the server using SFTP. Okay, if you use this. Oh, okay, perfect. I'll go on that. So we close this loop. So basically in this one, for each file, we'll calculate the mean for the cells that are relative to the Atlanta metro area. And these, okay, let's do this first. Let's see what, okay, I forgot the bracket. Okay. So as before, data is only one element in the workspace. But if we open HFX, we'll see that we have an array. It's just 4 instead of 8 elements because okay, I didn't restore this. Okay. So that again. Why still 4? Okay, yeah, of course, yes. This is 4. Okay, sorry. It's 4 because it's just 4 columns that we are considering for the mean. Okay, so then we create another variable where we calculate the mean of the averaged columns that we have calculated here. And we do this like this. And we can also calculate standard deviation for these means. And we can run. Okay, so as you can see, in the command window, we have the output of all the initial means, the column like means, because I didn't put a semicolon here. Now, okay, it's the index. Okay. Okay. Okay, now where all the semicolons are at their place, you can see that the command window is clean except for this one. Okay. So if you put semicolons everywhere, you won't have any undecided output in your command window. So let's have a look at the variables that we have created. So now this capital HFX should be 8, and in fact it's 8. So we have an average sensible heat flux value for each day that we have been considering, and that correspond to each file in our folder. Okay, these are the column wise averages. What else can we look at? Okay, we can look at the standard deviations. We also have 8 standard deviations value calculated for each day's means. So now what we can do is to plot this data in order to have a better sense of what's going on during the day of May 13, 2010 over Atlanta. So let's first, okay, it is very easy to plot something in MATLAB as easy like this. We could just write this. And we'll have this plot. But we can make this better looking because we cannot assess, well, what is this 1 to 8. We know we have 8 files and stuff, but we can give instructions to make this plot looking better. So for example, we can create another vector that corresponds to the actual times. Yes, Matt. So the standard command, the standard deviation command put in that place of the loop of the script is calculating the standard deviation associated with the second mean, with this one, with this mean. So it's not the standard deviation relative to the means of each column, but it's a standard deviation relative to the averaging of the 4 columns, the 4 averages, column averages that you have for each day. That's why at the end we'll have 1 sensible heat flux value per day and 1 standard deviation value. But you can do this also in at this stage. You can call it 2. I'm not super strong in statistics, so I don't know if this would make sense, but you can still do that like this. Oh, no, you're right. Oh, I see what you mean. Yeah, you're right. Oh. No, maybe.
No, I was just saying that if you want the standard deviation over all the cells, the mean works where the mean of the means is the mean if the sample sizes are the same, but the standard deviation I don't think works like that.
Yeah, as I said, I'm not super strong in statistics, but I'm showing the function to calculate the standard deviation of a averaging, but yeah, probably this is not the most proper way to do that. And I apologize about this. Okay, so let's go back to plotting. Yeah, okay, let's create like an array that will reflect the actual timing. Although this 26 will be like 2 a.m. the next morning. And so we add this vector t to our plot, and we can also, for example, change the color. This way we'll draw it red. And we can change the width of the line to have it thicker. And it will look like this. Although now it extends the plot size up to 30. So one thing that we can do is to limit the x-axis length. And we can do it like this. X equals GCA stands for get current axis. So now we have the same exact plot as before, but with a correct dimensioning. Okay, we can tweak this even further. And for example, we can add a 0 line to highlight the difference between positive fluxes and negative fluxes. And we can do like using the function that I showed you at the beginning with zeros. So basically we create a vector with 1 row and 26 column. And here in the plotting section, we use the command hold on that allows to overlays different stuff in the same plot. And so we give the command to plot also our 0 vector. And a nice way to show it is like this. That will be like a dotted line, horizontal line. Let's see. Okay, so this way we know that like sensible heat fluxes over Atlanta for 13th of May 2010 are negative until more or less 7 a.m. They're positive until almost 8 p.m. and then they become negative again. But maybe we also want to have a better idea of single points on the plot. So we can add a grid like this. And to increase the readability, for example, we can add further lines to the grid, for example, having one for like a finer gridding, and we can do this like this. Okay, let's make it quicker. So maybe we want also to give it a title. And we can decide the font size for this. Let's say 60. Now we can add axis labels. And a legend, although we only have one line in this plot, so it's not strictly necessary, but just to show you how that works. So we can run this again. What's wrong with we missed a minor grid. Wait, why? Okay, yes, because it doesn't know. Okay, so this mistake was good. So it's like MATLAB needs its instructions to be in consequential order. So this before was here at the bottom of the script, but so this didn't work. Now it should be should give a different outcome. Yes, so we see that the grid is it's finer now, so we can also get a more precise idea. And in this here we can also manually modify, edit our plot. For example, okay, using this edit. No, wait, tools. Yes, edit plot. Let's say, for example, so I made a typo here. So I click twice on the title. It's very slow, but it should open a window to change this to, okay. Okay. Another feature that this has is that you can retrieve a value on your plot using this. It'll give you the exact value. So this is the time, it's 11, and you have 202.9 watts per square meter, which is a sensible heat flux at this time. And this plot kind of makes sense because the sensible heat flux is a measure of the heat coming from the ground, from the surface, and that depends on insolation. And we can see that it's negative, so during nighttime, and it starts growing more or less around sunrise. It grows up to more or less 2 p.m. and then it goes down back again, following pretty strictly the solar radiation pattern, the diurnal pattern. Okay, now if we want to show the error associated with our means, although maybe not extremely properly calculated, we can use the error bar function, which is built in MATLAB. And keep the rest like the same. Okay, so in this case, we'll have an error bar associated with every averaged value that we've calculated before. So it will give us like an estimation of the uncertainty, although I might not have followed the best procedure to calculate the standard deviation correctly. Unfortunately, at least this version of MATLAB doesn't have a built-in function for like shaded error bars. But so the last thing that I want to tell you about MATLAB is the MathWorks website, which is very useful, especially in its support section. So let me change the screen sharing. So here you can find a lot of help on almost anything, including functions that have been developed by other users of MATLAB. For example, let's see. And they're stored on, there are several. For example, there's people developed their own. On the right, you can see how they will look like. And so you can pick the one you want according to, I don't know, your preference. And this is just an example, but there are plenty of contribution to improve your own programming. And basically, you can either download it from GitHub, or usually what I do is I just open the function here, slowly, just copy and select everything. And I copy it and I paste it in my MATLAB editor, and so I create my function. So the only caution to use with this is to understand how the function works, because you have to match all the variables, all the parameters of the function when you call it. So for example, I think I can show you an example of that from some previous work of mine. Where is MATLAB? Yeah. Okay. Okay. This should work. No, it doesn't. So this is something that I always struggle with. It's like a small change. It's enough to mess with everything. Maybe it's easier if I can show you a plot. Okay, whatever. Nothing. Okay, it's too much complicated now. Sorry. But I hope you got the idea. Okay, so Oscar, are you there? I think we're done with this. Thank you everybody for attending. this workshop. Hope you got something out of it. I'm sorry if I wasn't like the best. I thought it was tomorrow. So I even like with the email I sent, I thought it was tomorrow. So I had to rush it to make it ready for today. But I hope this was better than nothing. Thank you so much for everybody for attending. And Oscar, I see I can stop recording this if you agree. I will do that.
Yep, that's fine. I can take care of the download, Aldo. Thank you.
Okay. Bye.
All right. Bye.
Bye, everybody.